video, we're going to talk about straight line motion, also known as particle motion. We're going to be talking about position, velocity, and acceleration. This video is going to explain everything and do some small examples. I will have a link in my description for a video with full examples, but this is the explanation video. So straight line motion is motion of a particle on a line. So this is going to be one-dimensional. The most common lines that we use are the particle moving along the x-axis or the particle moving along the y-axis. If we're moving along the x-axis, the particle is moving left or right. And if we're on the y-axis, the particle is moving up and down. The particle is always moving over time. So we're going to say at time t, the particle is at position blank, or at time t, the particle's velocity is blank. It's all with respect to time. So let's start with position. We generally represent the position equation with s of t. Other common ones are x of t or y of t. A lot of times we'll use x of t if the particle is moving along the x-axis, y of t if the particle is moving along the y-axis. This is the position of the particle, so where is the particle on the number line? So for an example, it says if s of t equals, here's the equation, is the position in yards after t minutes, find the position of the particle after 2 minutes. So we're going to take 2 and we're going to plug it into s. Simplify, we get 8 minus 8 plus 1, which is 1 yard. So we are at 1 yard after 2 minutes. We're also could be asked about displacement. That is the change in position over a period of time. So how many yards in this case have I traveled from time A to time B? You can also think of this as the net distance. We'll talk about total distance later. Displacement is the net distance. So our example, we have our same position formula, and I want the displacement from t equals 1 to t equals 3. So I'm going to find s of 3 minus s of 1. And I'm actually going to move this. Let's find s of 3 and s of 1 over on the side. So I'm going to plug in 3. We get 18 minus 12 plus 1, which is 7. And we get negative 1. So s of 3 minus s of 1 is 7 minus negative 1, which is 8 yards. So my particle's change in position from t equals 1 to t equals 3 was 8 yards. That's a little bit about position. Next, let's move on to velocity. So v of t is the instantaneous velocity of the particle. And instantaneous might ring a bell. V of t equals s prime of t. So take the derivative of position and you get your velocity equation. Velocity tells you two things. It tells you the speed of the particle and the direction that the particle is moving. So for direction, when v of t is greater than 0, the particle is moving forward. So if you're on the x-axis, forward is right. If you're on the y-axis, forward is up. If v of t is less than 0, the particle is moving backward. So on the x-axis, backward is left. On the y-axis, backward is down. When v of t equals 0, your velocity is 0, your speed is 0, your particle is at rest. It's not moving left or right, it's not moving up or down. Speed is the absolute value of velocity. Your speed is always going to be positive. So take the absolute value of your velocity, and that will be your speed. So a couple of examples. Let's say they tell you v of 3 equals negative 7, and let's just say you're on the y-axis. That means at t equals 3, the particle is moving down. We know that because it's negative. Down, and I'm just going to say 7 yards per minute. So 7 yards per minute is my speed. That's the absolute value of -7. And I know I'm moving down because my velocity is negative. For the second one, I'm going to say at t equals 5, the particle is moving down 9 yards per minute. So same thing. The 5 is my time, so at 5 minutes, particle is moving down. I know that because my velocity is negative. The absolute value of -9 is 9, so my speed is 9 yards per minute. And then something I want to point out is notice between t equals 3 and t equals 5, my particle is moving faster. I went from 7 yards per minute to 9 yards per minute, but notice that your velocity is technically decreasing. So we are going to talk about that a little bit later, but I wanted to start it right here. You may also be asked to find average velocity. Now, average velocity, that's an average rate of change. So that is going to be your displacement over time. This S of B minus S of A over B minus A, that's like a slope formula. This should look really familiar to you. So we're basically finding the slope of our position equation over time. So notice that there is no V of t in this equation, in this expression, even though it's asking about velocity. So it's a common thing. There's no V of t in it. So for an example, we have our same equation. It says find the average velocity from t equals 1 to t equals 3 minutes. So I'm going to find s of 3 minus s of 1 all over 3 minus 1. And then this is the same expression, the s of 3 minus s of 1. We found that that was our displacement from the previous page. We got 8 yards. 3 minus 1 is 2. 8 divided by 2 is 4. And this is a rate, so this is 4 yards per minute. So my average velocity, on average, my particle was moving 4 yards per minute from t equals 1 to t equals 3 minutes. They could also ask you to find the instantaneous velocity. Now, instantaneous velocity is your v of t. So I want to find v of 2. Because velocity is the derivative of position, I'm going to take the derivative of my position formula. So the derivative of position equals velocity, and that derivative is 4t minus 4. I want v of 2, so I'm going to plug in 2. And I get 4 yards per minute. And I just want to point out, it is a coincidence that these two answers are the same. I also want to say, they could say instantaneous velocity, but sometimes they just say velocity. If they just say velocity, they mean instantaneous velocity. They will say average velocity if they want you to find the average velocity. So there's a little bit about velocity. Next, we're going to talk about acceleration. So A of t represents the instantaneous acceleration of the particle. And A of t is the derivative of v of t, which means it's the second derivative of s of t. So the derivative of position is velocity. Derivative of velocity is acceleration. So a little bit about acceleration. When acceleration is 0, the velocity is constant. And notice that makes sense because the derivative of a constant is 0. So if my velocity is constant, my acceleration is going to be 0. If A of t is greater than 0, velocity is increasing. If velocity has a positive slope, my A of t, my slope of my velocity, is going to be positive. And then on the flip side, if A of t is less than 0, velocity is decreasing. The next thing is a lot of times you're going to be asked if the particle is speeding up or slowing down. So we have 4 scenarios. For the first one, I just have a little example over on the left just to kind of explain it. Let's say at time t equals 2, my velocity is 3. That means that my particle is moving to the right, 3, let's just say yards per minute. And let's say my acceleration is 1. And so if my acceleration is 1, let's just say my velocity is linear, just to make it easy. Let's say at v of 3, then my velocity is 4. So now my particle is moving 4 yards per minute to the right. Notice that your particle is speeding up. So when v of t is greater than 0 and a of t is greater than 0, your particle is speeding up. For our second scenario, let's say v of 2 equals 3, so I'm still moving to the right 3 yards per minute. And let's say a of 2 equals -1, so my acceleration is less than 0. That means that your velocity is decreasing. And then just to make it easy, let's just say my velocity is linear. V of 3 then, let's say, would be 2. Notice that your speed is decreasing. So I'm going to say when v of t is greater than 0 here, and a of t is less than 0, your particle is slowing down. Next scenario, now let's say v of 2 is -3. So my particle is moving to the left 3 yards per minute. And let's say a of 2 equals +1. That means that your velocity is increasing. So then let's say at v of 3, let's increase my velocity. My particle is now moving 2 units to the left per minute. So that means that, notice that my speed is decreasing, even though your velocity is increasing because it's negative, but my speed is decreasing. So when velocity is less than 0 and acceleration is greater than 0, my particle is slowing down. Our last scenario, if v of 2 equals -3, so now I'm still moving to the left 3 yards per minute, and a of 2 is -1, my acceleration is -1, that means that my velocity is decreasing. So then let's say by v of 3, let's decrease my velocity. I'm still moving to the left, but now I'm moving 4 yards per minute, so my speed is increasing. So my particle is speeding up. So these are the 4 scenarios. I want you to notice that when my signs are the same, so this scenario and this scenario, when the signs are the same for velocity and acceleration, the particle is speeding up. When the signs are different for velocity and acceleration, the particle is slowing down. So this is a little bit of explanation for particle motion or straight line motion. Again, if you would like to see full examples, check out the video linked in the description. Thank you for watching.